Okay, for today's topic, we're going to be learning about similar triangles. Okay, so similar triangles are useful in making calculations and interpreting measurements. They're especially useful to estimate measurements for things that are too large to measure. Okay, and we'll show you a couple examples of those going forward. Okay, just a few notes here before we get going. So the sum of the angles in a triangle is always 180 degrees. Okay. If two corresponding angles in two triangles are equal, then the third will also be equal. Okay. And I'm just going to show you an image of what I mean here. Okay. So here's a triangle. And if this theta 1 and theta 2 are equal to theta 1 and theta 2, then by default, theta 3 is going to equal one another. Okay. If two triangles are similar, if any two of the three corresponding angles are congruent, so remember, corresponding is if they're in the same relative location, and congruent is if they are the same. Okay, so two triangles are similar if any two of the three angles are congruent, or one pair of corresponding angles are congruent, and corresponding sides next to the angle are proportional. Okay, so that's if we have theta 1 and theta 2 up here. Okay, side 1. Okay, so if theta 1, theta 1, if these s's are proportional, then these two triangles would be similar. Okay, lastly, two right angles are similar if one pair of corresponding acute angles are congruent. Okay, so remember a right angle there. Okay, if one pair of corresponding acute angles are congruent, so if these two angles equal one another, these two triangles will be similar because this angle and this angle must equal one another, right? It's kind of like if we know two angles, we know the right angle here and this theta and this theta, then these triangles are similar. Okay, so here we have two triangles and we're looking for the length of n. Okay, so note we have similar angle, okay? And we have two known side lengths, okay? So we know that these triangles are similar because we know two of the corresponding angles are congruent. So let's just go ahead and find that scale factor first, okay? So scale factor, let's call this one the new over here. And this is the old, okay? Again, it doesn't really matter as long as we're being consistent. And remember the scale factor is new divided by old. Okay. And sorry, just with my calculations, I'm going to call this one the new. And this one's going to be old. My apologies. Okay. So we know on the new one, we know 5 inches is the one side, and on the old is 2 inches. So we're just doing this calculation to find the scale factor. So this gives us the scale factor of 2.5. Okay. So now that we know the scale factor, we can apply the scale factor and this measurement to find n right there. Okay. So let's do a little bit of algebra here. So scale factor I'm just gonna move that over a little bit. Scale factor is equal to new divided by old. And we are solving for old n, so we'll multiply both sides by old. Okay, anything divided by itself cancels. And we need to divide by scale factor to get old all by itself. Okay, so now after we did a little bit of rearranging, old is equal to the new measurement divided by the scale factor. So the new measurement we said was 7 inches, and the scale factor is 2.5. We punch those into a calculator, and we get our old slash n equaling 2.8 inches. All right. So just a little bit of a review of what we've been doing for the last couple of days of this week. Okay. Now we're just doing this with triangles. All right. So in each of the triangles below, so triangle ABC is similar to XYZ. Okay. So triangle ABC, so ABC is right there, is similar to XYZ. XYZ, okay? So triangle ABC equals triangle XYZ because they're similar. So therefore, side AB is going to equal side XY. Okay, so we know this is side AB. So 6.1, and then side XY is 4.5 centimeters. So we can use those two sides. Those are my corresponding sides, right? Remember, we need to use the corresponding sides to find scale factor. So we will use those two sides to find that scale factor. Okay, so let's we're going to call this one over here an old one, and the one on the right is going to be a new. Okay, and our scale factor is old divided by new. Okay, and it doesn't really matter, old divided by new, new divided by old, as long as we're being consistent, because we're just applying ratios. Okay. So old is 6.1 centimeters, and my new is 4.5 centimeters. So punch those into our calculator, and we get a scale factor of 1.35 repeating. Okay, so we can use that scale factor to find that side X. Okay, so like we said, my side AB equals XY. My side BC is going to equal my YZ side. Okay, because they're similar triangles. So this side is paired with that X. Okay. So we are solving for new. So we have to do a little bit of algebra right here. So scale factor is old over new times new. Those cancel. Divide by scale factor. Okay. So after we arrange that, we have new is equal to old divided by scale factor. Okay, my old measurement is 5.3 centimeters. Scale factor is 1.35 repeating. Okay, don't just put in 1.35, put in that whole number. We want to be as accurate as possible. Okay, and we get our new measurement, or side X, equaling 3.9 centimeters. Okay. So these next two examples are very similar to the one that we just did together. So I would encourage you to pause this video, try these next two examples on your own. Actually, sorry, this one, try on your own to see go ahead and wait for me because that one involves another step. But it's review from earlier in the year. So if you feel like you're ready to try 2C, go ahead and try 2C as well. Okay, for 2B, so we have corresponding sides, so 18.8 and 8.2. It is stated that these triangles are similar. So let's go ahead and just find that scale factor. Okay. Let's call this one old, and we'll call this one new. My bigger one is going to be my new one. Okay. So scale factor is old over new. My old measurement is 8.2 feet. My new measurement is 18.8 feet. So that gives me a scale factor of 0.436, a bunch of ugly numbers. Okay, so I'm not rounding that number because it's my intermediate. All right. So because you guys have already manipulated for this formula to solve for new, you can go ahead and use that, but I'm just going to show this one more time to solve for that new. Okay, so scale factor is old over new. We'll multiply both sides by new to get it out of the denominator. Okay, those cancel. Divide by scale factor. New equals old divided by scale factor. Okay, so our old measurement, so now we care about this guy right here, and we're solving for x. Okay, so my old measurement was 12.7 feet. My scale factor is 0.436, and all of those decimals. Okay, I'm not rounding. Okay, to punch that into your calculator, and we get our new measurement, or our x, equaling 29.1 feet. Okay, if you got that one right on your own, I'm very proud of you. All right, so we will continue here. Note that we have a right angle, and note that we know the hypotenuse on our larger triangle, but not the hypotenuse over here. Okay. Note that we are looking to find C, but we don't know the corresponding side over here. So this one's a little bit more tricky. However, we do know two sides on this large triangle. And hopefully you're yelling at your screens. You're like, oh, we can do the Pythagorean theorem. Okay, so remember a squared plus b squared equals c squared, where c is my hypotenuse, and then a and b are just my legs. Okay, so let's go ahead and solve for that red side for my b squared. Okay, so we need to subtract a squared from both sides to get b all by itself. And then to get b by itself, we need to get rid of that squared. We'll take the square root of both sides. So b is equal to the square root of c squared minus a squared. Okay, so b equals the square root 25 squared minus 16 squared. Okay, punch those into your calculator, and we will find that side is 19.2 centimeters in length. Okay, this side over here, 19.2. Okay, so now that we know that missing side length, we can use the pair of corresponding sides, those sides that we do know, to find that scale factor. Okay, and then we'll go and apply that scale factor to find what that missing side length C is. Okay, so scale factor, new over old. Okay, So we will call this one new. We'll call this one old. Okay, so 16 meters divided by 4 meters tells me my scale factor is equaling to 4. Okay, so now that we know the scale factor, let's use this known side length now to find that missing side length C. Okay, so scale factor is equal to new over old. We want to find what that old is. Multiply both sides by old. Divide both sides by scale factor. That new side is 19.2 centimeters. Again, don't round our intermediates. Divided by our scale factor of 4 gives us that new measurement, that side C old, sorry, I should say. Old is going to be 4.8 meters. Okay, so a little bit of algebra, a little bit of Pythagorean theorem, and a little bit of new stuff here too. Okay. All right, let's keep on motoring. Okay, so this question here, so given that triangle ABC is similar to triangle RST, we have a couple dimensions of triangle ABC, and we're looking to find a missing length in triangle RST. So let's draw these triangles first, just to help us visualize the problem. Okay, so here's triangle ABC. We know AB is 6 centimeters. Remember, this is side AB over here. BC is 5 centimeters long. Okay, and that other triangle, and they're similar. So RST. RS is 8 centimeters long. Can we find the length of the second side? Find the length of the second side in triangle RST. Can you find the length of the third side? Okay. So we have a pair of corresponding sides, so we can find the scale factor, and we know that they're similar. Okay. So can we find the length of this third side? Well, let's find this missing side first, and then we'll address that second problem. Okay. So we have that pair of corresponding sides. So let's find the scale factor, and let's call this one old, and we'll call this one new on the left, on the right. Okay, scale factor is old over new. Okay, so old is 6 centimeters, new is 8 centimeters. So that tells me my scale factor is equal to 0.75. Okay. So now that we know the scale factor, we can go ahead and solve for that missing side length. So let's go ahead and do that. Okay, so X, we'll call that one green, and that's going to be new. So we got to solve for a little bit of algebra. So scale factor is equal to old over new. Multiply both sides by new. Divide by scale factor. New equals old divided by scale factor. Okay, my old side was 5 centimeters. And my scale factor was 0.75. So punch that into calculator. That new, or my X side, I should do this in green, is going to equal 6.6 repeating centimeters. Okay. Could we find the length of that third side? No, we cannot. Without knowing those angles, that third side, at this point in your math careers, you do not have the tools to find that third side. Yeah, so don't worry too much about that. That third side could be anything. All right, let's continue. So Carmen thinks any two isosceles triangles would be similar. Use examples to prove or disprove her belief, excuse me. So first we should address the question of what is an isosceles triangle. Okay, so that is where we have two sides and two angles are the same. Okay, so isosceles triangles, two sides and two angles are the same. Okay. So are any two isosceles triangles going to be similar? So I would encourage you to pause this video and consider this question for a moment or two. Maybe chat with a peer and then come back once you've had that discussion. For me to prove or disprove this example, I'm just going to draw two different triangles here. Okay. So in this isosceles triangle, so these two sides are similar and these two sides are similar as well. So let's say these are 75 degrees. And remember, any two angles or all the interior angles of a triangle must add up to 180. Okay, so if these two angles are 75 degrees times 2 is 150 degrees, meaning that this angle up here must be 30 degrees, right? 180 minus 150 equals 30 degrees. Okay, in my next isosceles triangle, okay, it's a little bit different, but those are my parallel sides. And my angles, okay, even if this one is 45 up here, and I know that these angles must be similar, okay, or congruent, equal to each other. So 180 minus 45 degrees equals 135 degrees, okay? Now that 135 degrees must be split between those two last angles there. So if I divide that by 2, I get 67.5 degrees angle. And right there from that one example alone, these two isosceles triangles are not similar. Therefore, any isosceles triangles will not be similar. Okay, so if you're asked to do a question like this on an assessment, two examples just like this would be actually perfect. All right, let's continue. Okay, so Rod notices that a 2-meter pole will cast a shadow of 5 meters, and a second pole will cast a shadow of 9.4 meters. Okay, how tall is the second pole? So let's draw our two triangles. Okay, so here's one. My pole is 2 meters in height, and the shadow is 5 meters in length. Okay, for my second pole, a little bit bigger. The shadow is 9.4 meters. And we're asked to find what that height is. Okay, assuming that these two triangles are similar, we have a pair of corresponding sides here. So let's go ahead and find that scale factor. Okay, let's call this one the old, call this one the new. Okay. Hopefully my assigning of old or new is not driving you insane. Like I've mentioned before, what we call old or new is completely arbitrary as long as we're being consistent with our calculations. Okay. So scale factor is equal to old divided by the new. Okay, so old measurement is 5 meters on those corresponding sides, divided by 9.4 meters. So that tells me my scale factor is equal to 0.531 ... Okay, I'm not rounding that, I'm just lazy. Okay, so now that we've found that scale factor, let's go ahead and solve for that new side. Okay, so again, we'll do a little bit of algebra here. So scale factor is equal to old over new times new, both sides. Anything divided by itself cancels out. Divide by scale factor. New equals old divided by scale factor. Okay, my old corresponding side is 2 meters. Scale factor is 0.531. Punch those into our calculator and we get our new measurement is 3.76 meters. Okay, and let's go ahead and write a sentence because it's a word problem. Pardon me if I forgot to in the last couple of examples. The second pole, and let's round this to the nearest tenth, is 3.8 meters tall. Awesome. Okay, let's continue. So assuming that a slope of a hill is constant and a point 100 meters along the surface of the hill is 4.2 meters higher than the starting point, how high will you be if you walk 250 meters along the slope of the hill? Okay, so again, let's go ahead and draw a picture to help us start solving this problem. So a point 100 meters along the surface of the hill is 4.2 meters higher than the starting point. Okay. Now that's our first triangle. If we walk 250 meters, how high will that, how high will we be? Okay. Great. So there is a couple ways to do this. So we have a pair of corresponding sides. So we could go ahead and find the scale factor and then apply the scale factor to find the new measurement. Okay. Or, and because we've been doing those other strategies for a while, I'm going to do a little bit of a trig review from the beginning of the school year. And I'm going to instead find this angle of inclination first, and then do a little bit of trig to find this side length, okay? Because if it's a similar triangle, we can apply that degree. It will be the same degree as in the triangle on the right-hand side there, okay? So from this angle of reference, 4.2 meters is going to be my opposite. Okay, this is a right angle triangle. And that 100 meters is going to be my adjacent. Okay, so remember SOHCAHTOA. Okay, and what ratio has opposite and adjacent in it? That is tan. So tan theta equals opposite over adjacent. Okay, now I know opposite and I know adjacent, and I just want to know what theta is. So to solve for theta, we must take the tan inverse of the opposite over adjacent. Okay, so theta is equal to tan inverse of 4.2 meters divided by 100 meters. And that tells me my angle of inclination is 2.4 degrees. Okay. So again, that is an intermediate calculation. We're not asked to find what is the slope of the hill, but because they're similar triangles, I know that this angle is 2.4 degrees. And now I can go ahead and solve for my opposite side over there. Okay, so this is still a right angle triangle that is opposite, and this is adjacent. Okay, so now I know what my theta is. And we are still dealing with opposite and adjacent. Okay, and now we are just solving for the opposite. Okay, so currently we are dividing opposite by adjacent. So to get opposite by itself, we must multiply by the denominator. So multiply both sides by adjacent. Okay, anything divided by itself cancels out. Now to calculate opposite is equal to adjacent times tangent of theta. So adjacent is 250 meters times tangent of 2.4. Okay, pop those into your calculator and we get a number equaling 10.5 meters. Okay, so hopefully if you decided to solve it how we've been doing it previously, you get a similar answer. Okay, now let's just answer this question with a statement because it's a word problem. Okay, so if you walked 250 meters along the hill, you would be 10.5 meters high in the air. Awesome. Okay, last question to go. So Mariam is sewing a patchwork quilt. The sketch she has drawn is to a scale of 1 to 8. Part of the design consists of right triangles that will have legs that are 2.2 centimeters and 4.6 centimeters long. What will the lengths of the lengths, what will the lengths of the legs of the triangles in the finished quilt be? Okay. So the scale, learn how to spell, is 1 to 8. Okay, this is a sketch. She's making a quilt, so it's getting bigger. And let's draw a sketch of what she's looking at. Okay, so right angle triangle, the legs are 2.2 centimeters and 4.6 centimeters. And the scale is 1 to 8. So 1 centimeter is getting multiplied by a factor of 8. Okay. So to find the length of the finished quilts, let's just do one side by side, or one side at a time, okay? So 2.2 centimeters is multiplying by a factor of 8 over 1. Okay, so that is equal to 36.8 centimeters in length. Okay, that's for this side right here. And now let's do the base. So 4.6 centimeters times 8 over 1. That is equal to, oh shoot, I got those numbers mixed up. Okay, so 2.2, I apologize. 2.2 times 8 is 17.6 centimeters. And then the 4.6 times 8 is going to be 36.8 centimeters. My apologies. Okay, so let's answer this question with a statement and finish up this lesson. Okay. So the legs of the triangles on her quilt will be 36.8 centimeters and 17.6 centimeters in length. Okay. So hopefully this is starting to make sense to you. Yeah, so if you have any questions, please feel free to reach out, send me an email, ask for help. And now that you have watched this lesson, please feel free to start working on 6.4 practice problems. Thank you for your attention and have a great day.